Okay, so our Common Core standard really is, today, it's going to be rational exponents, which is a fancy word for a fractional exponents. Because the whole word rational means fraction, okay? 1, 9, 18. We gained 1 minute of daylight today from yesterday. It's a long haul. Okay. Alright, so first of all, number 1. So we're going to rewrite this as the, okay, we're going to take the 8, and we're going to make it a cube root, because it's the bottom number, okay, cube root of 8 squared, okay? Now there's 2 ways to tackle this, okay, and I want you to listen carefully. 2 ways to tackle this. One is I could square the 8 and make it 64, but then I deal with big numbers, okay? That will work. I can take that and make that 64, and then look at the cube root of 64. That will work, okay? I prefer to try and make it small first, okay? So I usually like to do the root first. If I can, you can do one or the other. It does not matter. My personal choice is always to try and make it small first. So the cube root of 8 is 2, right? You guys agree with that? Cube root of 8 is 2. So what I've done is I've made this problem manageable. So I've made it 2, that's 2, squared, which is 4. If you'd done it the other way, and you cube the 8, you get 64, and you just wanted perfect cubes, right? Cube root of 64 is 4, okay? All right, example 2. The only difference in example 2 is the negative, all right? We have to be careful of the negative. We've got a negative exponent. So I'm going to make it 1 over. Before I do anything, it's going to be 1 over cube root of 8 squared, okay? All right, again, same problem, right? I know the cube root of 8 is 2, because 2 times 2 times 2 is 8. So I've got a 1 over 2 squared, which is 1/4, okay? 1/2 power is always square root, okay? 1/2 power is always a square root. It kind of makes sense. Okay, so I'm going to make this one. Am I going too fast? Am I okay? Okay, 1 over because of the negative, right? 1 over because of the negative. 1 over the square root. Now, normally we wouldn't write the square in there of 144 to the 1 power. Now, both these numbers I wouldn't normally write at all. So what we need to remember is this. Anytime you see 1/2 power, it's always square root. 1/2 power, square root. 1/2 power is always a square root, because there it is. You've got your 2 right there, and you've got your 1 there, but those are silly numbers, right? It isn't just square root, right? So you get 1/12, right? Right? Basically, square root of 144 is 12. We don't need the 2. It's implied, right? Everybody agree? You don't need the 2 there, okay? All right, now, example 4. Now, this is not so bad. We just want to go ahead and rewrite this, okay? We're going to rewrite it in fraction form. So I'm going to rewrite this as 7, okay? I'll move it over. This is going to be 7 to the 2/4 power. It's going to be 7 to the 2/4 power. There's my fraction. That's my power, and that's my root. Top part of my fraction, bottom part of my fraction. And I could obviously reduce that, make it 7 to the 1/2 power. Okay, that's all I want to do. I don't want an answer. Just want to rewrite it in fractional form, okay? Example 5, okay? Now, before I do example 5, when I multiply, same basis, I'm going to add exponents. It's the same thing. On a side note, here's my little side note. If I had x to the 3/5 times x to the 2/5, we would just add them and get x to the 5/5, okay? I was just adding exponents. You okay with that? So the only difference is instead of x, it's just 25. So that's all, okay? So I'm going to slide this back over. So I'm going to have a 25. Add the exponents, 3/5 plus 2/5 is a 5/5, right? Which is 25 to the 1 power. Well, that's just 25. Yeah, so I just added the exponents. That's all I did. And of course, they already have a common denominator. That made it easy to add. You agree? I kept it easy for us, huh? We didn't have to get a common denominator. Thank goodness. Okay, turn the page. How am I doing? Okay? Okay. Turn the page. All right, now, I've got, let me rewrite this so it's easier to see. 8 to the 4/3. Well, that's no good. Thanks, Megan. That's why you're here to help me. Over 8 to the 2/3. Okay? Now, when you divide bases, you subtract exponents. Okay? A little side note. We want to make sure we subtract exponents. So I'm going to get an 8. If I go 4/3 minus 2/3, I get to the 2/3 power, right? And normally I'd be done, but 8 to the 2/3 power, I actually can get an answer. In fact, we've done 8 to the 2/3 power. Oh, we did it right there, didn't we? See? So we can actually do this one. We actually did it here. So we may as well finish this one up because we know we can say, oh, well, that's the cube root of 8 squared, right? We did this one before, which same thing as the cube root of 8 is 2, because 2 times 2, 2 squared, which is 4, okay? Thumbs up so far? The same stuff we've been doing. Okay, example 7. Now we're going to be a little bit careful on example 7. I'm going to do this. I'm going to give this, it's kind of like distribute. This is going to go to the 27 and to the 1/3. It's kind of like distribute. So I'm going to go, oh, you can't see it. Doggone it. Okay, so I'm going to get 2/3 is kind of like distribute. I'm going to bring the exponent to both of them. So I'm going to have a 27 to the 2/3 power times an x to the, well, I got to multiply exponents, and I get a 2/9. Right? So I gave the 2/3 to the 27, and on the x to 1/3, I got to multiply exponents. Okay, so I just multiplied, and I got a 2/9. Okay, now 27 to 2/3 power. Okay, let's just do this one. That's the same thing as cube root of 27 squared. And x to the 2/9, you can't do anything with it. So I'm just gonna, I mean, you really can't. You can't. So I'm gonna leave it at x to the 2/9. It's kind of stuck with that ugly thing, but that's okay. Cube root of 27. What times what times what makes 27? 3, and then we know that 3 squared is 9. So I get 9x to the 2/9. I mean, I wish I could do something with that, but I can't. Okay. Okay. Example 8. There is no cube root of 56, but it might have one of these numbers in it, right? We can break it down. It might have one of these numbers in it, right? What do you think? 56. Do you see one of these numbers in it? 8. 8 times what? 8 times 7, right? So we could reduce 56 because we know it has one of the perfect cubes in it, right? So let's rewrite this as, okay, the cube root of 8, the cube root of 7, and the cube root of x to the 9th. How am I doing? I know what the cube root of 8 is. We all do. What's the cube root of 8? 2. Everybody agree? Cube root of 8 is 2. There's not a cube root of 7. It's just an ugly decimal number. But what are you going to do here? What do you think you're going to do here? Divide. And I'll show you why. I'll show you why. It is the same as a 1/3 power, right? We learned that earlier. So this becomes just a x to the 3rd. There you go, Simon, now you can see it. Now this cube root of 7, just like the square root, some things you can't reduce. So you're left with just keeping the cube root of 7 there. So we broke it down. We were able to break down the 56 into 8 times 7. And we were able to take 1/3 of the exponent, okay? Remember how we took 1/2 of the exponent? Now we're taking 1/3 of it because it's cube root, okay? All right, example 9. Okay, that's what we got. All right, I'm going to rewrite it so I can see it better. Fourth root, and they're both fourth roots, so I'm going to rewrite as fourth root of x to the 10th over x to the 4th. Since they're both fourth roots, I'm just going to rewrite it like that, okay? Because they're both fourth root, right? Okay, now, if I've got that, what I could do is I could subtract exponents, right? 4 of these would cancel 4 of these, right? And I'd be left with the fourth root of x to the 6th. Make a little bit of sense? Mason, you're thinking hard. I like that. You're thinking. Okay? And then that could be the same thing as x to the 6/4, or I like x to the 3/2 even better. Why not? Why not reduce it? How's that? Last but not least, okay? Almost done. Alright, example 10. I'm going to rewrite this as the cube root of x to the 6th over the cube root of 250, okay? Break it up top and bottom, okay? Two separate fractions. I'm going to take a third of the 6, okay? You alright with that? Make that x squared. But what am I going to do about this? Do you think one of these numbers might be in there? One of these numbers in there? One of these numbers in there? Is one of these numbers in there? Or is one of these numbers in there, maybe? Maybe? What do you think? Hey, what is this number in there? So 250 could be 125 times 2, right? Couldn't it? So I'm going to rewrite this as the cube root of 125 times the cube root of 2, right? How am I doing? This is a hard one. I like hard ones. Makes me think. Okay, x squared's fine. I like x squared. Let's leave x squared there. So I'll go x squared over 5. You okay with 5? 5 times 5 times 5? 5 times the cube root of 2. Slide roll. Uh-oh, we got a problem. We got a problem. We got a problem, right? So how are we going to get rid of this? Can't have a cube root in the bottom either. How are we going to get rid of that? You have to, you ready? Listen carefully. You have to make it a perfect cube root. You have to make it a perfect cube root in order to get it out of the bottom. I'm not going to multiply by 2 over 2. That wouldn't work. I need to make it an 8. I need to make it an 8 so it has a perfect cube root. Does that make sense? If you make it a 4, if you multiply by 2 over 2, it doesn't get rid of it because there's no perfect cube root of 4, is there? But I can make it an 8 by multiplying it by 4 over 4. So I'm going to multiply top and bottom by the cube root of 4 times the cube root of 4, okay? Let's see how that helps. Well, alright, I'm going to have now the cube root of 4x squared on the top. In the bottom, I'm going to have 5 times the cube root of 8. This is a hard one. I like this one. It makes you think. What's the cube root of 8? What's the cube root of 8? 2. And 2 times the 5 is 10. Okay. Cube root of 8 is 2. Times the 5 is 10. Now, what's left on the top is the cube root of 4x squared. Wow, that's a hard one, isn't it? Do you like that one, Keisha? Doesn't bother her. You have no love or like or dislike for it, do you? Okay, so we've got work to do, and we've got lots of time. It is, and I gave you the odds just in case you want to check your answers. Okay, 6, 14, 5 to 27, odd, and 99. Okay, and we have lots of time.